So welcome back, trend followers. This video is part 2 of a series that demonstrates how a trader who seeks to follow the path of a diversified systematic trend follower can achieve this with little to no programming experience through the use of new powerful software made available by Strategy Quant. Now, before we start, I want to apologise for any background noise, but there's a bit of mowing going on in the neighbourhood on this Saturday, and also I'm now using my workhorse computer here as we're going to be doing a bit of crunching in this video, and this particular workhorse PC has a very powerful fan because we undertake fairly intensive processing, and that might come through in the audio, so I apologise if that becomes annoying to you. I'm trying to tone it down through removing noise from my audio, but to a limited extent. So if you haven't listened to part 1 of this video series, then I strongly advise you do so to understand the context and appreciate how our approach significantly differs from the mainstream. This different approach to system development and portfolio compilation requires that we are very selective in the specific tools we use in SQX and in the workflow process undertaken. And it may appear counterintuitive to many who use these off-the-shelf solutions, but there is a reason for our madness. So in a nutshell, just to refresh you from part 1, this difference relates to our desire to attack the fat tails of the market distribution of returns, which are unpredictable in nature, as opposed to the predictable rhythm associated with the peak of the distribution of returns, which is the familiar target for most retail traders. Now, inevitably, all of us are caught to a degree with the general very efficient nature of the normal market distribution. But we as trend followers seek with intent to create trend following traps that operate on the edges of the normal distribution, which allow us to catch the occasional insect that strays beyond this protective envelope into the fat-tailed environment, where we will be waiting. Now, as discussed in the prior episode, the success of our technique over the long term relates to a number of principles that we seek, namely a divergent method that is unbounded in profit potential achieved by cutting losses short and letting profits run at all times, extensive diversification across markets, extensive diversification across systems, a small sample size per system that seeks to respond to more exotic trending environments that lie outside the everyday market churn, the use of simple trend following systems to allow for multi-market potential and the ability to cater to a broad array of different trajectories of trend in these exotic zones of non-normality, and strong positive skew of system returns. And this skew is a symptom arising from cutting losses short and letting profits run in an environment dominated by fat-tailed behaviour. These principles are essential to our philosophy, and some were explored in part 1 of the series. But to ensure that these core principles are embedded into every system design that we generate through the Strategy Quant X process, and don't leave it to chance, we use a design-first logic in developing core trend-following models before we even turn to Strategy Quant X to finish off the workflow process. Now, in practice, in creating a diverse trend-following portfolio, we develop many core designs, referred to as systems, that we then diversify around to create variation in entry, stop, and trail condition. The reason we diversify around these core designs is that our intent is to capture a broad array of different possible trend trajectories that can be taken in these fat-tailed environments, and importantly, to provide a degree of low correlation between these variations, which assist us in developing very robust, diverse portfolios using an array of these robust single system variations. But enough of the waffle. At the end of part 1, we provided an example of a simple core trend following design that we will now feed into the Strategy Quant X process to develop variations around. And you can see that design expressed on the screen at the moment. So Now that we're ready to proceed into Strategy Quant, let's go. Given that this is a demonstration and not a tutorial, we're going to take a shortcut through this process to provide a brief overview of our objectives. If our members want to get further into the detail, then just ask on the forum and we can lay out these processes in all their fine detailed glory. So let's first start with the data manager. This is where the market data is housed that you use to undertake your SQX processes with. And SQX currently has the capability of generating expert advisors in a range of codes for a number of different platforms, such as MetaTrader 4, MetaTrader 5, TradeStation, and multi-charts, and can be used for any liquid market and time frame. The multi-market and multi-time frame capability makes it ideal for the trend trader seeking broader diversification. So in the data manager, you have the ability to use SQX in-house data itself, such as Ducoscopy, and some very long-term data that I've imported from my own Pepperstone platform. Now, the Ducoscopy data we like because it's high quality minute data and it has a fairly extensive history, which makes it ideal for testing purposes. So most of our initial workflow process is conducted using this data. But we also use this long-range Pepperstone data from our platform that we trade live on to provide a final tick to all of our tests of robustness, but we will get to that later. Now, having multiple sources of market data, such as both Ducoscopy and the Pepperstone data, it's actually very useful for testing processes as it provides variation or a degree of additional variation around our data sample to test the robustness of our core design logic. Now, you will note that the data set that we use is tailored to the retail trader and comprises three broad asset class groupings of Forex, CFDs, and equity indexes. These CFDs are commodity-based CFDs. So with these broad asset class groupings, these are typically available to the retail trader on the MetaTrader 4 platform. This is unlike, say, the world of the futures trader who's using a different platform and is using direct futures data. We are restricted to the CFD world, or the contracts for difference, which imposes additional cost burdens on our trading strategies. And it makes them life a bit more difficult in addressing trend following and imposes slightly different biases on the data series. And as a result of this additional bias associated with the increased costs of trading CFDs and Forex and equity indices using CFDs within our retail environment, we therefore need to develop core design variations within each separate broad asset class. Yes, we do have multi-market capability, but our multi-markets are defined within each broad asset class grouping. Also, you might note some of the data, as we scroll through the list, is referred to as cloned data. Now, this cloned data is Ducoscopy data, which is being converted into the time frame of our broker Pepperstone that we use for live trading purposes. The cloning function is a very handy tool used by SQX to allow us to reconstruct our time series to the time frame of your particular broker that you trade live on. In our case, the Pepperstone platform uses the universal time coordinate UTC +2, which includes daylight savings. So in undertaking our testing using Ducoscopy data, which uses UTC of 0, we therefore need to recompile that data into clone data of UTC +2, which includes daylight savings. Just before we leave the data manager, I thought I'd introduce you to another powerful feature of SQX. Because we can download tick data or minute data into our software here, it gives us the ability to recreate bars of any time frame duration. For example, within the MetaTrader 4 environment, it is standard practice that you are restricted to the M30, the M5, the M1, the H4, the daily, the weekly time frame, but given this ability to reconstruct our own bars from this smaller time frame data, we can construct any time frame we like for testing purposes within the SQX environment. This gives us a unique ability within our testing context to define more unique time frames that are not commonly applied by many other retail traders. But for the purposes of our trend following, we do stick to the medium to long term time frames such as the daily or the weekly time frame, given our understanding of the impacts of noise on the trending condition using those smaller time frames. So that's why we tend to stick to the longer term time frames, and we've discussed that in prior broadcasts. So that's a broad overview of the data manager. Now, rather than bore you to tears with all the other modules, many of which we don't use for our trend following purposes, we'll get straight to the custom projects module here. This is where all of our work is done. So when you enter the custom projects, you'll notice that we've already created a single custom project for demonstration purposes. And the beauty of this process is that a project contains a diverse sequence of workflow tasks that may take months to achieve if you don't have systems such as SQX at your disposal. So all the effort is spent upfront in their creation, and once created, you can reuse them without having to go through the painstaking process of setting them up again. So once you have created these projects and you want to reuse them later, then it is as simple as opening the existing project and clicking the Start button. So let's drill down into this project and see what's going on in more detail. Now you'll see on the left-hand side of the screen a series of sequential workflow tasks that commence with the Build Strategies task, then the multi-market test, followed by the slippage test, a full sample test, a recency test, a Pepperstone full data test, and finally a final fixed dollar risk test. These processes are undertaken in consecutive order and progressively hone in on the core design variations that are both robust and have demonstrated a tendency for recent outperformance. The intent of this process is to ensure that the solutions are not only robust performers and have demonstrated a long historical track record across a broad array of different market conditions, many of which have been unfavourable, but also that this process allows for adaptive markets and recognises that our workflow process needs to address this market adaptation and its influence on the trending condition by undertaking a recency test that biases our selection towards more recent trend following solutions experienced over, say, the last 5 years. Now, this does not assume that we can predict a future path, but rather provides an adaptive method that ensures that over long-term horizons, our technique progressively adapts in light of new market conditions that may emerge as we navigate an uncertain future. Now that was a bit of a mouthful and probably a bit difficult to absorb, so it might help if you can understand the intent of this process. We undertake this process periodically at, say, 6-month or 12-monthly intervals, where we invest our effort in developing diversified trend following models using this workflow process. The result at the end of the exercise is a portfolio comprising features of robustness and features of recency. Now, this does not mean that we have any idea of expected returns in the future, but rather it is an outcome of our processes that firstly undertakes a comprehensive robustness phase to only select those systems and market solutions that have stood the test of time, and from that robust selection, we then only select those candidates which have clearly expressed outperformance over a rolling 5-year period. So undertaking this process gives us 2 historic trajectories arising from a single collection of solutions that have been created through our 6-monthly process. We have a baseline trajectory that describes how the collection of strategies developed in this 6-monthly generation process stack up against very long-term data sets. And we also have a recency trajectory that reflects the performance of these robust solutions under more recent market conditions. Now, the robustness trajectory associated with this entire collection indicates that the recency trajectory is not curve fit to noise, but rather curve fit to more recent trending conditions of the market. Now, this recency trajectory is a best case path that is very unlikely to be exceeded in an uncertain future. But if more recent conditions prevail into the future, a slight bias may be imposed that allows our future path to lie somewhere between the baseline projection of robustness and the optimal recency trajectory. So in undertaking this workflow process on a 6-monthly basis and replacing tired, poor performers with a new generation of sharp solutions with recency embedded in them, this process seeks to always keep the portfolio sharp and current as it contains an adaptive element. It is important to note that while a recency window rolls forward on a 6-monthly basis, the robustness phase progressively gets longer and longer in terms of date range lookback. We want our robustness phase to use as much market data as we can get our hands on. For this is our only method of ensuring that we can detect system weaknesses in any of our solutions using historic market data. While the future is uncertain and new market conditions that have not been experienced in the past are very likely, at least we have ensured that from what history has presented to us so far, we have some very robust little cockroaches in our trend-following arsenal. So we have briefly discussed the overall intent of the sequential workflow process. We can now look at the solutions that have been generated in each phase of this process. And here we refer to the data bank, where we have got different tabs that relate to the different phases of the workflow process. You can see that this sequentially orders the results from the build strategies phase on the results tab to the multi-market phase on the multi-market tab, the slippage phase to the slippage test, the full sample phase, and so on, that steps through the sequential workflow process. And you'll also note that the initial collection that are developed during the build strategy phase progressively gets honed and reduced in number by basis of a validation process integrated within each of these workflow tasks that progressively hone the sample from the broad collection to a fine-tuned result, which goes through a process of this robustness testing and this recency testing. The end result of the process is where we are left with the Pepperstone full results, which are applicable to our particular broker's data. And in this final tab, this is where we then compile our portfolios based on results generated through Quant Analyzer, which we'll get to in another episode. But look, I've looked at the time again and things are getting away from us, so this might be a time to wrap this particular episode up. So what we'll do in the next episode is we'll commence with the data bank of results, a look at some of these interesting little information notes generated by SQX. It tells us we're doing a wrong thing, but we have a different idea about that. And then look at the individual componentry within the different workflow tasks, just briefly and broadly, as it's quite a comprehensive exercise, and this isn't an instructional video. And then following that, we'll then go to the portfolio compilation phase, engage within Quant Analyzer, and then subsequent to that, we'll be putting this onto our broker's platform and showing you a demonstration of a backtest of a result of a compiled suite of solutions generated through this process. So that's a wrap for this episode, and stay tuned, as shortly we'll produce another episode that gives a further overview as we delve further into this process. So thanks for watching and have a great trading day.